Before watching this lecture, you should know the definition of exponentiation when the exponent is a natural number. In this lecture, we will extend the definition to cases when the exponent is a rational number or a real number. We begin with the case when the exponent is equal to 1 over n and n is a natural number. For example, 9 raised to 1 over 7 is defined as the 7th root of 9. That is, 9 raised to 1 over 7 is the solution to the equation x to the 7 is equal to 9. To figure out what 9 raised to 1 over 7 is, we can do some trial and error. For example, 1.4 raised to 7 is around 10.5, so 1.4 is a bit high. 1.3 raised to 7 is around 6.27, which is a bit low. Thus, 9 raised to 1 over 7 is a number somewhere between 1.3 and 1.4. And we can find the exact value simply by raising 9 to 1 over 7, and we see that it's equal to 1.369. In general notation, for any natural number n, a raised to 1 over n is defined as the nth root of a. If n is even, it's the principal nth root, that is, it's the non-negative root. If n is even, a raised to 1 over n is only defined when a is non-negative, while it's defined for all real numbers when n is odd. Next, we define exponentiation when the exponent is the negative of 1 over a natural number. For example, 9 raised to minus 1 over 7 is defined as 1 divided by 9 raised to 1 over 7. Thus, 9 raised to minus 1 over 7 is defined as 1 divided by 1.369, which is around 0.73. We can check this using the calculator. If I do 9 raised to minus 1 over 7, I get the right answer. A simpler example, 8 raised to minus 1 over 3 is the same as 1 divided by 8 raised to 1 over 3, which is 1/2, since 2 raised to 3 is 8. We now have a definition of exponentiation when the exponent is a rational number with the numerator 1. We will now define exponentiation with an arbitrary rational exponent, where the numerator can be any integer. For example, 9 raised to 3 over 7 is defined as 9 raised to 1 over 7, which we have previously defined, this whole thing raised to 3. 9 raised to 1 over 7 was 1.369, which means that 9 raised to 3 over 7 is the cube of 1.369, or 2.564. We can check this by doing 9 raised to 3 divided by 7, and we get the same answer. In general notation, for any integers n and m, a raised to m divided by n is defined as the nth root of a raised to m. If you look at this from the right to the left, you see one of the power rules, since 1 over n times m is m over n. The power rule is a result when exponents are natural numbers, and we use it to create a definition when exponents are rational numbers. Here is another simpler example. 8 raised to 2/3 is equal to the square of the cube root of 8, or 2 squared, which is 4. Since any real number can be approximated to any precision by a rational number, exponentiation with an irrational exponent can be calculated by such an approximation. It's important to know for which numbers exponentiation is allowed. Here are 2 useful rules. Exponentiation is always allowed if the base is greater than 0, no matter what the exponent is. In this case, the power will always be positive. Also, exponentiation is always allowed if the exponent is an integer, with just one exception, and that is when the base is 0. If the base is 0, then exponentiation is allowed if the exponent is a positive number. The power rules are always valid if the exponents are integers. However, they are not in general valid with rational exponents. For example, minus 2 squared raised to 1/2 would be equal to, according to the power rules, minus 2 raised to 2 times 1/2, which is minus 2 raised to 1 or minus 2. However, this is not the correct answer. Minus 2 squared is equal to 4, and 4 raised to 1/2 is 2. There is one important case when all the power rules are valid, even with rational exponents, and that is when all the bases are positive. Having extended powers to allow for real exponents, let's revisit the expression a raised to b is equal to c for the case when all numbers are non-negative and b is not 0. In this case, a raised to b equal to c is true if and only if a is the bth root of c, which is the same as c raised to 1 over b. Thus, if I know the value of the power and I know the exponent, then I can find the base. For example, the equation x raised to 2/3 equal to 6 with b equal to 2/3 has the solution x is equal to 6 raised to 3 over 2, as 3 over 2 is what you get when you calculate 1 over b, or 1 divided by 2/3.